So here we'll be dealing with the harmonic analysis of cantilever beam. So that is the experiment for today, harmonic analysis of cantilever beam. So first you have to open Abacus software. So click on Abacus CAE. So once you open the software, you can choose the first step as to create a part. So click on create part. So 2D planar, type is going to be deformable, and base feature is wire because it's 2D. So click on wire, continue. So next you can see this display is going to create the wire model. So you'll be seeing the screen. Click on create lines. So click on any 2 points and then right click, escape. Right, so next you click on the dimension, you give dimension to this. So dimension is 5050, enter. So you can see that line of 50 dimension is created, close and done. And next we'll give property. So first create material, click on create material, mechanical, elasticity, and then elastic. So we'll give two values, Young's modulus and Poisson's ratio. Young's modulus value can give 2 e power 11 and Poisson's ratio is 0.3. And next is general density value. So we'll be giving the density value 78580, right? So can give this value and then click on OK. So after giving density and value, next is to create profile. So we'll be creating a rectangular profile. So click on rectangular, continue, and we'll give the values. The width is 0.01 and then the thickness is again 0.01. So give the values, click on OK. Next go to create section. So it is going to be a beam section, category is beam and type is also beam. Continue, and then we'll use the default options and you click on OK. So after creating section, you have to assign the section. So click on assign section, click on this line, done, and assign the section 1, beam, and material is material 1. So click on OK. The next one is to give beam orientation, assign beam orientation, click on that, then click on the line, next click on done, and then use the default ones, enter. You can see these two arrows and then OK, which means the beam orientation is assigned. Next is to go to the assembly module. In that, create instance. So click on instance part, part 1, dependent, mesh on part, click on OK. And next is to create the step. So click on step. So create step, initial, the procedure type what we will be using is linear perturbation because again dealing with harmonic analysis. So click on steady state dynamics, direct, it's a dynamic analysis, right? So continue. Next it will ask for the various frequency, lower and upper frequency, right? So give lower frequency as 6 and upper frequency as 55 and number of points in between as 14, 6, 55 and 14, and then you can click on OK. So rest all you have given default values, click on OK. And next is load, click on the module load. So create boundary condition, click on that, mechanical, So displacement or rotation type, continue. Since it is a cantilever beam, you know that we are going to fix the left point, so click on the left end, OK, and in that we are going to restrain all 3 degrees of freedom, so u1, u2, u3, and click on OK. So now this point is fixed. Next, you create a load. So mechanical load, what we are going to give is a concentrated force, continue. So the point where the load is applied is on the right end, so click on that right end, done, and then we'll give the value. F1 is in X direction, so it is 0. CF2 is in Y direction, so give the value as minus 100, right? So X0 minus 100, so it is 100 newtons acting downward on the right hand end. Click on OK. You can see that an arrow mark, yellow arrow, which denotes the force. So next, click on the next module, which is mesh. Object should be part, and then seed part. You give the approximate global size as 10 and apply. OK, and next you click on mesh part. OK to mesh the part, yes. So now the mesh has been created. Next module is job module, where you have to go to job manager, click on that, create job 1, model 1, continue. Here what we are going to do is full analysis, default options, OK, and then you submit this model for analysis, right? So the warning will show job files already exist, OK to overwrite. Just click on OK, and here you can see it has been submitted for analysis, and then you can see that the abacus completed successfully. So the job 1 is completed successfully. Then you can click on results. Once the status is completed, click on results, and in this you click on plot counters on deform shape, right? So here you can see the first model. Then you go to this option, which is to create XY data. Click on that, and then ODB history output, continue, and next use the option which is strain energy and save as XY data 1. Okay, so click on OK, and then go to plot. So here you can see the strain energy versus frequency plot, right? So go to XY data manager, click on that. So XY data 1 strain energy, so current session, so you go to that and you can edit. Once you click on edit, you can see X is the frequency, Y is the strain energy. You can change that strain energy value to displacement, so click on displacement and give OK. And then click on plot. So now we'll have the graph of displacement versus frequency. So in different frequencies, what is the displacement of your cantilever beam, right? So it is displacement versus frequency. So this is your harmonic analysis result, where you can plot for the frequencies which we had mentioned from 8 to 55. So that is what has been plotted. So this is how you do harmonic analysis in